Hello, everyone. So we are Julian and
Hey, I'm Willie.
And we work for Datakin. And today we're going to talk about data lineage with Apache Airflow using OpenLineage. So putting OpenLineage and Airflow together to get some real-time lineage and observability. And of course, Datakin is the principal sponsor of OpenLineage and Marquez. Marquez is the reference implementation of OpenLineage, and Astronomer is the company behind Airflow. And on that, there's one more thing we wanted to talk about and announce today. And bear with me on the microphone. And so we have been acquired by Astronomer, and so we now join forces. And it makes a lot of sense, of course, to have operations and observability together. And you can have a healthy feedback loop and make sure your DAGs run properly and be able to see it and really get observability working together.
Yeah, and the key thing with Astronomer, I mean, they're so key to the Airflow community. So they've been contributing back, and they become the de facto standard to run your workflows. And at Datakin, we were trying to solve the lineage problem. It's a really tough thing. So we came up with a standard called OpenLineage that we'll go into, and it just makes so much sense, especially when we met the team. We're all super excited to join.
Yeah, it makes your, and there's a really shared DNA on open source, obviously, and makes your observability actionable. And of course, Datakin still accepts signups for the service, and we keep supporting our users while we're integrating in the Astro Cloud. And on that, we'll get to our presentation today. So today, we'll talk about the need for lineage metadata and OpenLineage and Marquez, which is an open standard for lineage collection. Marquez is the reference implementation. And then we'll go in the more practical part of the presentation, talking about the actual observability in Airflow. Excuse me, there's a lot of lag on this screen in the front. Thank you. So the key for is data lineage. Really, it's really important to be able to understand for each job what dataset it's reading from and what dataset it's writing to, and for each dataset, not only who produces it, but who consumes it. Right? So it's kind of at the core of this talk, and really thinking about lineage, and not only lineage in what dataset is derived from what dataset or column, but really understanding the processes which transform this data, and really understanding this lineage as the bar graph of dataset to job to dataset to job graph, where the metadata around the transformation is also very important. And so the first step is to really enable building this healthy data ecosystem. So usually, if you think of an organization growing and different teams start consuming and producing data, usually within a team, you have good practices and people know how things are running, how dependencies work, what are people supposed to do, and how they're supposed to produce data. However, as soon as you have team boundaries, that's where you have a lot of friction, because people don't necessarily know how data gets updated, where it's coming from, the semantics between certain things. And that's typically as teams grow and they become more data aware and produce more data, that's where a lot of the friction happens. Uh-oh. Don't speak next to the speaker. Okay. And so you have this limited data context. And so it's really like, okay, we have this data, but where's the data source? What the schema is supposed to be? Is it changing? Who's the owner? How often is it updated? Where does it come from? Who's using it? What has changed, right? So there's a lot about the current state of the data, the current schema, but also how it changes over time and who creates those changes. And so it's really important to collect that metadata as things are happening and capture how it changes over time, so that you can get more context and reduce that friction. So we've been borrowing this data hierarchy of needs I mean, so Maslow came up with the Maslow hierarchy of needs, and there's a lot of, if you want to achieve happiness and so on, there's a bunch of fundamental things you need to get first. You need to have food, you need to have shelter, you need to be in a safe space, and then you can work on, once you have the basic needs filled, that's where you can try to reach for happiness or get the best person you can become, right? And so if you apply that to data, you know, before you actually can get value out of your data, there's some basic things you need to attend, right? So one, the data needs to just be available. You need one way to get it in somewhere you can look at it. Second, it needs to be fresh, and so the data should not be too old or outdated, right? It needs to be updated in a timely fashion. And then it needs to be correct, right? Once you get data flowing and it gets in time, you need to make sure it's actually correct, there's no problem in it, and you can actually use it. And a lot of time in data engineering of like all the data practices is spent on ensuring those things, right? And as long as you don't achieve this, you have your head underwater and you can't really achieve what you want to do with your data, which like the first step is most of the time business optimization, making data-driven decision, and then like finding new opportunities. What next? What else can we do with your data? So there's really, the baseline is about keeping our heads above the water and being able to use that data and be in a space that we're not constantly fighting it and making sure it's correct and working. And so that's where we started the OpenLineage project. It's really as a way to define an open standard for the collection of lineage as the pipelines are running, right? Which is really important. So really this aspect of instrumentation and taking a page from the OpenTelemetry book and not just looking at lineage after the fact inspection, but really instrumenting things as they're running. So we have very precise and very granular metadata. And so to start this project, I really took a page from previous open source projects. So, you know, I started the Parquet project in collaboration with Cloudera when I was at Twitter, and then later on, I contributing to launching the Apache Airflow project. And so there's a lot about when you want to build momentum for an open source project, you need to get this critical mass at the beginning, right? Especially for those types of projects which are standards for building something for the community. It's really important we can get together so we can reach out in the community, get on the same page. And you know, most of the people I talked to were on board with, of course, we need a standard for lineage. How come we don't have it yet? And the reason we didn't have it yet, because someone needs to get out there and push the project, get people together, and like get to the point where we can have a common way of collecting lineage. And so we did that, and we were lucky enough, you know, through the existing data communities to have a lot of people either giving feedback or contributing to the project and so on, and really initiate this snowball effect where, you know, the more people contribute to a standard like this, the more it becomes valuable for everyone. And so there's really a snowball effect, and I've seen that happen for Parquet, I've seen that happen for Airflow. It's really, once you put enough effort and put in the community towards everyone, every single new contributor and new user of the project adds more value for everyone, right? And so there's really building this momentum that gets the project going and gets those standards adopted. And so one of the key directions for the OpenLineage project is really to say the best time to collect metadata is when things are happening, right? When you look at a picture, you could say, well, there's a lot, you know, we could use machine learning and AI and stuff to figure out metadata. Sorry, the screen just turned off. And enable capturing information, you know, what time was it? Maybe you can infer that from the height of the sun. You can figure out the location, how it was on the coast. But the other way is you can just instrument the camera so it saves the metadata as things are happening, right? So modern cameras save the GPS coordinates, the time it was taken, a lot of information of how the picture was taken. And that's exactly what OpenLineage is. OpenLineage is the EXIF metadata for your data pipelines. And so if you think about this ecosystem, And like there's a lot of people who consume Lineage and a lot of people who produce Lineage. And today, all those projects, there's several open source projects or proprietary software who consume Lineage. They all need to talk to each other. You know, you have this N square effect of a lot of communication, a lot of having to agree on doing things, a lot of duplication of effort. And once you define your own a shared standard like this, well, it simplifies the problem a lot because now a producer of Lineage can focus on producing Lineage in this shared format. Consumers can focus on consuming it. And there's just a lot less duplication of effort, a lot fewer conversations, it's a lot simpler, things are streamlined. And also, because we define this API, we can actually push the Lineage instrumentation into each of those projects instead of looking at it from the outside, right? Like the great vision in the future is like everyone posts Lineage in an OpenLineage representation. There's a lot less of always catching up, of inspecting the internals of each of those things for figuring out Lineage. So the way it fits, and you know, this was the slides we did at the beginning, like kind of defining the vision of OpenLineage. It's about 3/4 there. From these slides, it's really about making all the producer expose Lineage and enabling a bunch of consumers to consume that Lineage. And the reason is there are lots of use cases behind Lineage, and there are a lot of specialized tools that look at it from a different point of view, whether it's operations or governance or privacy or a lot of other things. And it's important to enable an ecosystem that can all leverage Lineage and really amortize the cost of this. So the data model, there's on purpose a very simple data model that focuses on just the Lineage. You know, this notion of recurring jobs, and we capture each run of the job, and it has inputs and output data set, right? So that's the core, it's just the Lineage, and then there's very extensible model on each of those entities in that model. We can actually add facets, and facets, and I will get back to this, are these things that really enable putting more metadata. They are self-contained pieces of metadata that you can attach to those entities. And so the way this works is when the job starts, we send a start event with metadata related to it. When it finishes, we send an end event, so it's all very asynchronous. Makes it easy to consume that metadata from different consumers and keep track of things. So typically, you know, you have a life cycle of a job run. It starts, and it either completes or fails or aborts. And you know, in different contexts, those jobs are called different things. In Airflow, it's a task. You know, in Spark, you have commands that are doing things, and you can model those things as OpenLineage jobs. And capture the start and end state, whether it's successful or failed. And the facets are really these atomic, self-contained pieces of metadata. Each of them has a JSON schema that define them. So they're self-documenting, right? They have a name, they have a schema, they're self-contained and can be designed independently that avoid this effect of having a big monolithic spec, right? We can focus on different aspects, like people who care about data quality can focus on the data quality aspect, data quality metrics. People who care about a column level Lineage and governance can focus on that. Oh, thank you. And they're flexible and scalable in terms of making decisions, right? And we allow also custom facets that let you extend the model without having to go through an approval process, right? So you can either have the common core facets that are going to be defined as part of the spec, or defining your own custom facet and really make the model extensible so you can experiment and build on top of OpenLineage without having to go through any kind of approval process. And so just a few examples, you know, to give you an idea of the kind of information. On datasets, you may want to capture the schema, and that the schema at the time of the dataset, that the dataset was read or written to, what statistics you had on the dataset, data quality statistics. On the job, you would capture what's the version of the code, what was the plan at the time of the run. You could capture other kind of information, query profiles, and so on the run. And like I was saying, the dependencies are endless, right? The big value, I think, this shared instrumentation of Lineage, is there a lot of use cases that can be built on top of this. So of course, Datakin is focusing on observability operation. Does my data show up? Does it show up on time? Is it correct? And really this kind of operation aspect of things. But there are a lot of people who are interested in other things, like ensuring privacy regulation, like does my user private data go in the right places? Are we not consuming it where we're not supposed to consume it? Or discovery, understanding where data is coming from, and all other use cases that can be applied to this. And on that, I'm going to pass the microphone to Willy, who is going to talk about Marquez, and Marquez is the reference implementation and store for OpenLineage event.
Cool. Okay, thank you, Julian. Okay, so a little backstory about Marquez. So both Julian and I, we work and we co-created the Marquez project there. And eventually that project got donated to the LFAI and Data Foundation. So we're really excited to talk to you about Marquez and also the influence Marquez project had on OpenLineage and walk you guys through a demo and some background. Okay, so what is Marquez? Marquez is an open Lineage implementation. It also is a metadata service, so it exposes a Lineage endpoint to extract Lineage information. So what we look into the payload when we receive it, we look at sources. So where is your data? Where does it live? How do I connect to that source? You will look at data sets, and those could be they could be tables, they could be a file on S3, and then the jobs themselves, so the code that actually executes. We also care about the job entity and what are the inputs and outputs. So if you look at the diagram on the right, you'll see there's different use cases. So your ETL jobs, so Airflow is one example, and a few others. There's batch, and also we're looking also to improve the OpenLineage spec to also support streaming. But streaming data sets are something that's supported in Marquez, and you post that metadata through a REST API. And then the certain features. So if you look at data governance, sort of understanding who has access to what data. And so the way you kind of do that is usually you tag your table or you tag your columns using the REST API that Marquez has. And that way you know, does this table have PII? If it does, what are the jobs that are reading from that table that possibly could be pushing that PII data downstream? The other one is data lineage. This is a pretty key thing to Marquez. So the model on the back end will keep dependencies between the jobs and the data sets that they produce and consume, as well as link those to runs. And data discovery and exploration. So Marquez does have a search API that you could use through the UI or just hit the REST API directly that allows you to search data sets and jobs. Right now, fairly simple, but we are looking to expand that to do a bit more interesting things. So if you remember, as Julian presented on the OpenLineage model, you have runs, you have jobs, and you have data sets. Marquez goes a bit deeper, so there's a versioning layer that is on top of that. So with jobs, you're going to have batch streaming and so forth. But for every job that you admit or register with Marquez, we also do version it. It's super lightweight. We kind of look at, has the code changed? Because you report that back, the link to GitHub of where your code might be. We also look at the inputs and outputs. So has the inputs and outputs for your job changed? We also version on that. And then we associate a run to a job version. So we're constantly knowing for every run, what were the job versions that were produced and what were the dataset versions that were produced, and also what were the dataset versions as input, and what was the transformation that happened. For datasets, there's different types right now, but they usually associate them to a source. So you have S3, you have Postgres, MySQL. So all those you want to register, and then if you look from left to right the model, you begin to register data sets, you begin to register jobs, and now you have this really simple catalog of information, and on top of that, you have the lineage graph. So what are the design benefits? Like why invest or why have a model that captures all that information? Really the debugging case. A lot of the time, you're a data engineer, you're given some SQL from an analyst, like productionize this and run it once a day or weekly. But sometimes that code changes, that SQL does change. And when that change happens, how do you know that, or when do you know that that bug was introduced in your code? Because usually it's about a week later that your dashboards don't look right. Either you're doing really well, or it doesn't make sense, like we didn't push out a new feature in our product, yet we're seeing the numbers, there's an anomaly in the data. So the real question you're asking is what version of the code produced what version of the data set? And once you actually find out what the problem is, you want to backfill your data, and that's a really tough problem right now. Do you want to backfill all your data? So you want to do full processing. So if you process all the partitions of your data set, or do you want to do incremental processing? So the next part of my talk is going to be around Airflow observability with OpenLineage. So we're going to go a little bit deep into how the integration works with Airflow. So how does the support for Airflow work with Marquez? So the one thing that we look at is that when your DAG runs, you have to have the Marquez library installed, but these slides are a bit old now. We've been moving so quickly in adopting the standard. Now you just have to install the OpenLineage library. So real quick backstory. The integration for Airflow started on Marquez, and then we donated the library to OpenLineage. So what does it collect in terms of metadata? The task lifecycle, I mean, that's just your basic. Your job starts, it's running, did it fail? The task parameters, so what are the parameters that go into your job? So the common question is, are you providing a flag that maybe executes in certain parts of the code? So you want to collect that to help you debug later. You have the task runs that are linked to version code, so the integration does support. If you are syncing your code from GitHub, we're able to build that link and report it on the back end. And the most important thing is just the inputs and outputs. So if you have a Postgres operator, and you look at the SQL, what are the what tables are you writing to? Yeah. Lineage is also another big one, right? So a lot of the time, organizations they run multiple Airflow instances, sometimes just one, but you don't have a common view of all the DAGs that are running. You normally have to click on a DAG, look at its task, and look at the graph. So what we end up doing is collecting the lineage information and understanding the inter-DAG dependencies between the DAGs themselves and also the tasks. And then there's a built-in SQL parser. So this is pretty lightweight. We just tokenize the SQL. We look at what were the input tables and also what table did you eventually write to. And we have this link code builder. So this GitHub supported, GitLab. And the other important thing is just the metadata extractors. So they're the ones that look at the operator and extract the metadata at a surface level and then report that to the Marquez backend as an OpenLineage event. And a really high level, sort of capturing the metadata from Airflow and sending it to Marquez. So from left to right, you have DAGs that execute. You're using the OpenLineage integration, and that reports those OpenLineage events to Marquez. And Marquez then eventually populates the backend model that allows you to then query the API or look through that metadata and explore it via the UI. Yeah, another quick thing here. Currently, you do have to modify your DAG. We've actually been working with a team at Astronomer and also the Airflow team about introducing a task listener. So you won't have to modify your DAGs. This is just kind of a really quick way. It's supported through all different Airflow versions. But as of, I think, Airflow 2.3, there's a task listener, and it will support this plugin, which will simplify the introduction of OpenLineage and collecting that metadata. But the library is open source. You can now go to OpenLineage, and really you just have to modify your import. And what really happens here, so the library looks at an operator. Usually there's an operator that you're using to query some data, and the extractor looks at what are the input parameters, what was the what actually happens when the DAG runs, it registers all those different tasks to the Marquez backend, and then extracts the data. So mostly we look at that SQL parameter, and then we parse it, and we then look at the source. So what source are you connecting to? So that way we could register those data sets with the job. And then we bundle that up and send it over. And really quick here, so we're going to go through just the sort of steps that happen as the extractor looks at the operator. So for one, we initially look at the Postgres connection ID, and that's super important because when we register the data set, we also want to pull in the schema in sort of as a job is running. So here we have analytics DB for our job, so that this is going to be our source. Cool. And then we register the data set. So after we tokenize it, we kind of looked at, okay, we have this really simple new room. Oh, this is the task ID. Okay. All right, well, we skipped a step, but there's room bookings is the input table, and the job itself is called new room bookings. And so that's what really happens every time one of your DAGs runs. So here we have two DAGs. They run periodically, and maybe one team owns one DAG, another team owns another, but they're not really sure the relationship that exists between the two. They just know that, hey, this has to run periodically. And the connection that exists is really the tables in between. So to have dependencies between tasks, that's an option, but really if you want to understand if your DAG fails, and let's say if you push out some new code and you're corrupting your data, you want to be able to know what was that input table that both DAGs depend on, and may possibly run a backfill. Okay, we should have the demo here. Okay, great. So in this example, we have two Airflow DAGs. Where do we? Or even in a recorded demo, it doesn't go right. Yeah, that never happens. Oh, hold on. Okay, we are further along in this than I thought, but that might be okay. Yeah, if you don't mind. Yeah, thank you. Okay, so we have two example DAGs here. We have one DAG that is called counter, and really simple and trivial for a reason. So the DAG itself, it's now importing the Airflow OpenLineage integration. So you just do a simple override there. So we have a DAG called counter. It's going to create a table if it doesn't exist. There's some SQL there. It says, okay, create table, and you can see they're both sharing a source because eventually it's going to do increment a counter and insert it. The other DAG is called sum. So the sum is just going to read from that counters table and sum it. So again, similar modification to the DAG using the OpenLineage import. For Airflow, similar thing where it's just sort of populating or creating some tables as a setup, and eventually it's just going to read from the counters table. So then we go to Marquez. So the DAGs are running. On the top right, you saw that I selected a namespace, and here, these are the different DAGs or different jobs that were registered. So this is what the lineage graph looks like. So the important thing with the integration is that it appends or adds the DAG as the prefix. So here you can see counter.inc. So the inc was the task, and it's in a complete state. We capture the SQL from the OpenLineage facet, and here are the facets that OpenLineage collected. And at the same time, we're capturing all the different runs. So this is currently in the running state, but you can see there's previous runs as well. And automatically, the data set was collected as well as the schema. So you can see here value and the type, and that was the schema for the table. And similarly for the job here, sum.total, running state, and again, you can see that we're reading from the counters table and doing a sum on the value, and eventually inserting it. And again, the different facets here. If this was a Spark job, you would see the Spark plan there. So with the different run history, we look at then the output table, and here you can see it's example.public.sums. The convention that we use there is that the name of the database plus the schema and plus the table. And you could also do some searching as well, like I talked about before, and you could do filtering on data sets and jobs as well, and do some sorting as well. But okay, that's cool. That's an interesting example, but what I wanted to do is make a change to the DAG. So I wanted to update the column name, which happens a lot, right? So oftentimes you have to rename a column, but how do you know who's using your table? So oftentimes you rename it, and eventually someone pings you. It's like, hey, my pipeline's not working anymore. What happened? Okay, so we're just going to do a quick refresh. And I think at this point the job finished. So if we go back, everything happens in real time. So you can see here that the table column has changed. So we're now inserting, I think it's called values from 1 to 10. So we're just only inserting values from 1 to 10. And you can see the column name has changed. Also, you can look at the different run history. So from run to run, you'll see that the initial run had value and the type was int. And then similarly, with the newest run, its values from 1 to 10. Also, there's different versions of the schema as well. Or we also version the data set. So if we clicked on any of those, you can see that initially, let's see its value. Okay, this is the job, I'm sorry. Yeah, so that job was reading the old column. Right. So eventually this job is going to fail. But let's not wait. It's not fun to see a job or wait it to fail. So if we want to skip really quick to 6:15, that'd be great. Yeah, we would have had to wait a long time. All right, perfect. So eventually I hit refresh, and what we end up seeing is the job failed. And we kind of expected that, right? Because the column name is no longer what we expect. So trying to insert or trying to read that column, your job would fail. So here, we just have to do a quick refresh. Sometimes what happens is it doesn't sync up because there's a time on it. So if we just refresh the DAG, you'll see that the run sum.total is failing. And you could link that to the run ID, but also the code, so we know why it's failing, or in this case, not quite yet, because we don't know that the column changed. So if we go and, so let's say we spoke to the team over Slack, and okay, this is a pretty simple fix. So we're just going to apply the change to the sum DAG. So now the DAG has been updated with the new SQL. I'm just going to wait for that to refresh. Okay, great. And I think, so what we can do also, we can actually just check out the code for the DAG just to make sure that worked. And when we do, we scroll down and you can see that the code has been updated, and refresh the Marquez UI, and you'll see that the DAG should be in a running state. So we're really happy about that. So we solved the problem. Cool. And then, yeah, you could also see that we are reading the new column, so values from 1 to 10, and the pipeline is running successfully. But what I wanted to show really quick as well is, so you could use the Marquez UI, but there also is a REST API that's super powerful, so you can always hit the Lineage endpoint to get a graph for a node. So the node ID, there's a certain format that we have. It's going to be the type of node, the namespace, and also the job names. But if this was a data set, you'd give the data set name. And all we're going to be doing is just using JQ to run it, hit the API to get and filter on the graph just to get the counter.inc job. So what you get back is an ID, you get back a type, in this case it's a job and also the data. You get the name, there's a lot of metadata that exists in there, so the name of the job, the inputs and outputs. So if you were going to hit the job's REST API, you'd get back the same information, but now what you're able to see is a lot more detail. So you get back the latest run, so what was the latest run for the job, as well as what was the state, so the start and end times, the duration, the run args that were passed, as well as the version ID. So you could always reference a job version by its ID if you want to look at the code that was executed. We also have version inputs and outputs in the API. And then here you could always go back and look at what was the schema for that version by just using that version ID. You get back the context, and here is just a place to throw information. So you'll have the SQL that was executed, as well as the OpenLineage facets. And the one thing that we do add in the OpenLineage integration is the information around the operator, the task, the version, the Airflow version that we executed. And you can see here, we also have the in and out edges for that node. So the origin is going to be the job, and then you have a destination, which is going to be a data set. And the one thing I do want to highlight is that the way we register data sets is through the source. And the one reason why we do that is you might have the same table name, especially if you copy data from one source to another, you're going to have conflicts there. And also from staging to production, that's also a possibility. So we wanted to link it by source. And one last thing, all this information is stored in a lineage events table, so all this is logged. The schema itself, you have the event time, the event type, but we're going to do a quick select on this table to get the event history. So we're going to get the event time, the event type, the job information, and print that out. And I think the important thing here is Marquez is just one example of what you can do with OpenLineage. These events, they could be routed to different systems as well. So as this information is coming in, you could apply your own logic on top of that. For Marquez, it's cataloging those jobs and data sets and applying versioning and exposing a lineage graph. But there's more to it than just that you can take this where you can take to standard. All right, thank you. And I think with that, what we wanted to say was thanks for attending our talk. We do have some information that will eventually come up here. Okay, great, yeah. So if you want to learn about OpenLineage, check us out on Twitter or GitHub. Same thing for Marquez. There's been some amazing new information that's been put up on the Marquez website, and thanks to Ross, who's in the crowd. He's done a lot of really amazing work on the website, and yeah, you could talk to us on Slack, but also after hours.
Oh, and we have stickers for Marquez and OpenLineage if you come ask questions.
All right, thank you.
Thank you, guys. Great presentation.